that I must have met you in a past life. Got my heart on the floor, go slow. Keep me falling for you all night. Tell me now, you're the one I've been dreaming about for my whole life. Had you on my mind, oh. Hear the sound of your voice in the crowd, calling my name, yeah, you captivate, oh. You captivate me. Cover me in a dream of love. You're pulling on my sanity at the seams. I need you next to me. Can't get enough. I don't wanna miss your energy. So tell me now, you're the one I've been dreaming about for my whole life. Had you on my mind, oh. Hear the sound of your voice in the crowd, calling my name, yeah, you captivate, oh. You captivate me, you captivate me, baby, baby. Ooh, it's almost too much to take. Baby, you captivate me. Ooh, with you's where I wanna stay. Baby, you captivate me. Tell me now, you're
Hello, everyone. Hello. Welcome back to another episode of Workshop Wednesdays in partnership with Girls Who ML. We're super excited to have you. If you are in the building, in our virtual building, when you're tuning in, please let us know where you are tuning in from. I'm tuning in from the beautiful city of New York. Baby, it's getting warm. Listen, skies out, thighs out. I shouldn't say that, but you know what I'm saying? We're excited. We're excited for lobster rolls and road trips. Anywho, welcome to Workshop Wednesdays. Today we have an incredible lineup for you. But first, some housekeeping. We want you all to know that we want all of your questions. We welcome all of your questions. So if you, like during the session, have questions, please put them in the chat. I will be starring them on the back end to ensure that we don't miss it. So please drop all your questions as they come. And then at the end, we will circle back and answer them. Second thing, please tell someone, lottie dottie, everybody, a fellow scholar, a fellow friend, that we are live. We are super excited, like I said, to have our guests. And we would love to make sure that we have a full room to support this talk. And then lastly, share. If you are on LinkedIn, please feel free to hit that share button. Please give a reaction and definitely comment. Obviously, if you're in YouTube, go ahead and give us a thumbs up. You guys can give us a thumbs up and make sure you're subscribed to our YouTube channel. We are on the road to 6K, which is super exciting. So please make sure that you subscribe. Thank you, sis. Please make sure you subscribe to us on YouTube. And obviously, if you're not subscribed or following us on LinkedIn, please make sure that you're following us on there as well. So wanted to definitely introduce our incredible speaker for today. We have Avantika, who is a senior data engineer at Accenture. She has over 7 years of experience building scalable data platforms and production grade pipelines. She specializes in the end-to-end data lifecycle from ingestion and transformation to orchestration. And so she's super passionate about simplifying the complex engineering concepts for the next generation of technologists, which we are also the same. She also is a fellow Grow with Google scholar with us in this current cohort and is a track lead for the business intelligence track. So let's give a warm welcome to the most amazing Avantika. Welcome.
Hello everyone. Am I audible?
Hello. We're super excited to have you. How is everything on your end?
Thank you. Thank you for having me. And super thanks to Mentor Me Collective and Girls Who ML for having me. And yeah, I'm so excited for today.
We're super excited to have you as well for today. Before we jump in, of course, we love to do a little icebreaker. So, if you could combine two superheroes into one, which two superheroes would you choose, and what would the superpower be? And I can start first just to kind of give you an example. So, my favorite two super heroes, one is Storm, and the other one is Wonder Woman. And the new name for my superhero would probably be Wonderstorm or Storm Wonder, something like that. Something like that. And their superpower obviously would still be to control the weather. And I think also control the weather, super strength, and the ability to transport, definitely. What about you?
For me,
Mhm.
my superhero has always been Iron Man because he's first of all he has many qualities. He is funny, witty, intelligent, and super humble person. Looking forward to know who all have the same um, common
I
common
agree.
superhero between us.
I agree. So before we jump in and share these slides, we'd love for you all to tell us what your superhero combination would be in the chat. Let us know of the new name and, of course, their superpowers. So while folks are populating that in the chat, I will also hand it over to you.
Thank you. So yes, please type in your favorite superhero, and I'll begin. So first of all, I would like to give incredible thanks to both Mentor Me Collective and Girls Who ML for having me. So I'm Avantika. As Chanel mentioned, I'll be your host, and uh, without any further questions, I would like you all to scan this QR and download all three files. Yeah.
And I'm just coming on here really quickly. So I just put the
So
link
you
in the chat.
can see the link in the chat. So you can also click the link and you can see all three files. All are HTML files. So one is handout. That will be your common file for entire session, and there will be another two files which are activity 1 and 4. You can keep it handy, and once the time comes I'll ask you to see that. Also, you can mention that from where you are signing for, so that I know uh, from where all the people are joining from.
Awesome. I just dropped the link. I'll drop it again. And yeah, you can feel free to start whenever you're ready.
Okay. Okay.
So Avantika, you're lagging a bit. I'm not sure if you hear us.
Yeah, I can hear you.
Okay.
So, is my screen up?
Yes, I see your slides, but you're lagging. So what I'm gonna do is just I'm gonna take you off screen. I'm just gonna focus the slides on the screen of your slides, okay?
Okay.
Okay. All right, you can continue now.
Okay. So, yeah, we can start. And here's a quick bit about me. I have 7 years of experience on building data pipelines across GCP, Azure, and Snowflake. in multiple domains: retail, life sciences, and banking. So right now I'm embedded in field services data engineering at a large retail client in Accenture. And yeah, so what I'm working is to make data usable. It is not just stored, not just variable, but also usable by ML models and AI systems. That's exactly what tonight is about, and we'll cover that. So, here's the agenda. We are having 8 sections, and there will be an interleave teaching activity where we will explore. We will explore. Every time I explain a concept, we will apply it immediately to a real scenario. And by the end of our session, you will have designed a complete end-to-end GCP data pipeline. So, drop in your favorite emoji who all are excited. I want to see all the emojis. Yeah. Okay. So, yeah, we can jump into next session. So, here is the problem. You can read it out. I'll explain. So, you have petabytes of data. Once you are working in a real world scenario, the data volume is always huge. And think that you are handling petabytes of data, and your cloud bill is enormous, and your team, although they are talented, but you have multiple models like ML and data engineering pipelines that still shows garbage predictions. Have you ever thought why? Yeah. So the answer is almost never the model. Almost always it's the issue with the data. So there are 3 reasons which I have listed. So data can be dirty, it has nulls, it can have duplicate values and schema issues, and model is always trying to learn from the garbage noise that it has. Second issue, the pipeline can be so hard, there is no linear tracking, something breaks at, let's say, midnight, and nobody knows what has changed. So we have to keep track on it. And third issue is AI needs to clean. Earlier, we didn't have the AI for to resolve all our issues, so we used to manually clean our data on timely manner, and we used to structure our data. There used to be multiple raw events where the model did not work. So all those issues we still have, and we are tackling that. So here's Priya. Priya is a GCP data engineer at a food delivery app. Her ML team wants real-time ETA predictions, and her data is a mess. So does that click? Anything? We are going to fix her pipeline step by step. So in this entire session, you will be fixing her pipeline, and you will be knowing how the entire pipeline works. So here is a so I hope everyone have downloaded the files from my link tree. So you can open activity 1 file. Can you all open that? So if you open the, let me put out the questions. So in activity 1, you will see the issue in the broken file. You have to spot the difference. So, can you all spot the difference? I would like Shannon to share the screen for activity one slide, if that is possible.
Sure. So you would like for me to share for activity one, is that correct?
Yes.
Okay. 1 second. I'll just go ahead and do that. And if you could let us know if you have access to it, just give us a thumbs up in the chat. If you don't, it's fine. We'll just go ahead and share the screen so everyone can see. Thumbs up if you see activity one, and if not, I'm going to go ahead and share my screen so you all can. Is this activity one confirming that's activity one? Avantika?
Uh, yeah, that's correct.
Okay, awesome.
So, you just go through the activity one. You see what's the difference in the pipeline and spot the issue. What went wrong? And at the end, there is a question. Um, one question together.
I think we might have, um, I think Avantika might have dropped. Um, Avantika?
Hello.
Okay, now we can hear you. Maybe if you turn off your camera,
Yeah.
that might help with the lagging.
Okay.
Okay,
Yeah.
perfect.
It should be good. So,
Okay,
can you spot the difference? That's a real world scenario. So, look carefully what went wrong, and at the end, there is a question: what may have went wrong? Is it schema that changed without the warning? Is it alerting was set up? Uh, is there silent failure for 2 days, or everything went wrong? So, can I see the responses on the chat? A, B, C, or D, whatever you feel is correct. Just respond with the answers.
sure. So for those of you who can see this on screen, we want for you to answer what went wrong. So we have some answers coming in. We have D from Hector. Ishami says D. Tia is saying D. Anyone else have any thoughts? Okay. And Chica is saying A. Valeria is saying D. Sandra is saying D. We have Itoko. I hope I'm saying that right. Also said D. So more folks are saying D. I did get one A. Any other responses coming through? Feel free to drop them below.
Yeah, most of the people are responding with the D. Yes, you all are right. So the culprit is always the combination of issues. So dirty ingestion, zero monitoring, and nobody catches the model is already broken in production. Everything went wrong together. So yeah, we will fix that issue together. And here we go to next slide.
Awesome. So I will 1 second
Yes.
after that. There you go.
So you can see in the left there are traditional ETLs, and in the right we have modern data stack. Let me let us go through that together. So earlier, Priya used to build a pipeline, and she used to incorporate ETL, traditional ETL, which ETL means extract, transform, and load. I assume people are aware. If not, then ETL translates to extract, transform, and load. So in ETL, we pull data, we clean, and then we load to warehouse. Simple. So Priya used to make night reports and Um, because it is traditional, it is always a batch, and the pipeline was very hard. And whenever the schema used to change, BI dashboards always used to fluctuate with the differences, but not ML. And Priya's team says, give me real-time features. Traditional ETL simply cannot because it did not handle the real-time real-time ingestion of data. Now, in today, we are having modern data stack. What's changed? Um, so, in we are currently using ELT. So earlier we used to use ETL, which was extract, transform, and load. Now we are using ELT, which is extract, load, and then transform. So we first load the raw data, transform in the warehouse, and then raw data is always preserved. So in ELT, in the modern data stack, we are having both streaming and batch data. So it is it you it stores the reusable ML features and data contracts, so team doesn't know the gap or each other's pipelines. They are aware whatever break, and in the real time only they are aware what break and how. So they use DBT, Airflow, Kafka, Spark, and all these structured streaming. And if we are considering GCP platform, then these map directly to managed services, which is exactly what Priya uses. So I'll be putting a question. Um, Let me put the question. Okay, let's read it out. So, question is, which would you put into PubSub first and why? You can open your handout document and you can see the PubSub on the left hand side. There you have a fill out and you have to fill in what would you put into PubSub.
Okay, would you like for me to share that as well, Avantika?
Yeah, just put the question on the chat.
Sure. Is this the handout you wanted me to share?
Correct.
Um, I hope everyone can see that. Feel free to give me a thumbs up if you all can.
So first we have ingest, and you have to write that is for your handbook. So you can write it or you can paste it directly on the chat. Which one do you think we should put into PubSub first? I can give you a hint. Event streaming are covered into PubSub. So is it PubSub event streaming we put into PubSub? Is it batches, processes we put, or data warehouse we store? You have all the options. What do we do with the ingest? Simple.
It says capturing live events from the app, but is it something a little bit more in depth?
Yeah. So that's correct. And we use live streaming, event streaming actually in PubSub. So yeah, kudos.
Can you explain that a little bit more when you say event streaming?
Correct. So, we are having all the live model that is handling all the real decisions, and we are getting all the data at live. So, think about that. Data is coming at real world time, and we have PubSub topic per event. So in the PubSub, we will fill out all the events, meaning all the data which is getting streamed directly and live. So that's what ingest is called, and that's what we will see. Um, what does real-time ingestion looks like, and what is the difference between real-time ingestion and batch processing. So, so yes, so yeah, we are having latency issues. We are having use cases depending on business requirement. We also have to consider cost and complexity of the model, and based on all of these, our model is decided and built. So let's go one by one. In the latency, um, for example, think like that. Priya's ETA prediction, she cannot wait an hour. So the latency should not be high, all right? Because if she has food delivery app and ETA prediction is so high, so all the results are going to lag. So the model, whatever she is going to build, the model should not predict for a longer. That's why we don't need high latency. Now coming to use cases, batch is always preferable, and it is preferable for reports, ETL loads, and streaming is for, let's say, live recommendation or anything where you need to act before a pipeline closes. Then we have complexity and cost. So, streaming, we all are aware that it is more complex, and it because it is more complex, it requires high cost, and that is why it is expensive, because infrastructure is always there to support the streaming, and hence the ratio between complexity and cost is equal. And what's the so on Priya's side, she cannot tolerate high latency, as well as she cannot tolerate high cost. All right. Now, uh, she has to decide what she needs. So, right now, as we all have gone through all the issues, latency, use cases, complexity, and cost, Priya actually needs all. So, streaming for live and batch for model training. She needs everything, and yeah, we have to pause and think why she needs both. So,
Hey, Avantika, I just want to tap in real quick. So some of the folks in the chat are saying that some of these tech terminologies are either new or they're not too sure what they mean. So let's, I guess, if you're open to it, I would love for us to kind of just break down what each of these words mean when we talk about even dimension or batch processing or real-time streaming. What do all of those concepts mean? And then also everything that is in the dimension column. Let's break that down as well so folks understand what they mean.
okay, so batch processing, think about it like we have large group of data which is coming at scheduled interval. So think about at your doorstep, after each hour you are going to have multiple group of people coming in. That is called batch processing. Are we good with that?
Yes, if
Give me a
everyone
thumbs up.
understands, yes, drop a thumbs up if you all are good with that. If you need us to double click or lean a little bit more into that, feel free to let us know in the chat. So yes, now leaning into the next wonderful buzzword.
Streaming, yeah, streaming data. What is streaming data? So think about, in the same example, think about at each second your doorbell is ringing with many people coming in. So 1 second one people comes in, another second another people comes in, and so on. So that is called streaming. So we are having people coming in frequently, one by one. Yeah. So does that work? Yeah.
Amazing.
Okay.
So how do we feel? Okay, one second. I just want to make sure that everyone is following. So regarding real-time streaming, how is everyone feeling about that? Give us a thumbs up. Okay, yeah. So when you say live real-time streaming, is the same thing live data?
Correct.
Okay, great. Just wanted to clarify that. And then now for the dimension, just talking about latency, use cases, complexity. Let's lean into those a little bit more as well.
Yeah. So latency means you have prepared a cake and your cake is getting delayed by 50 minutes to get ready. That is called latency because assume that your oven is old and it's getting um, issues while preparing the cake fast. So we are getting late and the cake is getting much time to prepare. I
Okay,
can give you
so
another
latency.
example.
Okay, perfect. Yeah, let's do that.
So think about that the people are coming in at your doorstep but slowly. Is that um, easy? Easy way to
I,
understand?
I think so. I think so. I guess I just want to clarify. So, latency is a measurement of time. Of course, we always want things to happen quickly, but processes can take time. But it also depends
Correct.
on, right, the kind of hardware and or maybe data center that this model is being deployed to that can take it from minutes to hours or milliseconds to seconds. So basically, again, it's a measurement of time. I know
Correct.
you also talked about obviously use cases. So of course, nightly reports, like if like a model is running and or said model or data process is running, it will tell you what, what's working, what's not, all those kinds of stuff. But you have ETL loads here. I'm not sure a lot of people understand what ETL is and what that means. Can you describe and go into that a little bit more?
So I'll first start with use cases. Um, Understand use case with the requirement. So business asks you to prepare reports, and that is having some rules that you have to follow. That is called use case. So yeah, sorry, what was your question, Chanel?
Oh no, the question was it wasn't a question. It's more so like, can you explain ETLs for some folks who don't know what that means?
Sure. So think about we want to move data from one place to another. How do we do? So for example, let's take an example. We travel from city to city. So let's say we are traveling from New York to San Francisco, and we are the data. How do we transport? We can transport by flight or we can drive. So that is our mode of commute. That is same how it goes for the data. Data also travels one place to another, or rather one storage location to another. That is what the mode of commute of data in easier terms. So are we good with that?
I think that was pretty good for me, but just want to make sure that everyone else feels good about that. So feel free to again put thumbs up in the chat if we're feeling good. And if you need us to talk a little bit more about that, you can drop that in the chat as well. Yep, people are saying that this is great. Hector says he's feeling like a genius now. Things are making sense. And we do have one question. So do you mean that these are the types of data processing into AI models? Is this what
Yeah,
this
I'll
means?
answer that.
Later
So
on,
you
right?
mean these are the types of data processing into AI models? Yeah, I handle this just after explaining what is ETL and ELT. So thinking about the same commute example, um, Yeah, so ETL means we are ready for traveling, and we want to change into our tracksuits or whatever um, whatever dress we are comfortable for traveling, and then we are reaching at the airport for traveling, and then we are reaching the destination. That is ETL means extract, transform, load. We are ready. We changed into a new dress. Then we are traveling, and then we are arriving at the destination. Now ELT means we are ready. We directly go to the airport and we reach the destination, and then we changed into our required outfit. So that is called extract, load, and transform.
Oh, amazing. Amazing. And then, of course, you mentioned some of these tools, um, like Spark, Hadoop, DBT versus Kafka, Flink, and then Spark Streaming. Um, can you talk a little bit more about the difference in these tools for batch processing and real time streaming?
Sure. So, Kafka, DBT, ETL are all the modes. Let's understand this way. They are all the modes of transforming data, or let's say a platform where we can use ETL or ELT operations. Are we good with that?
Amazing, 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 and everyone in the chat is following, so we love that. You talked about data volume, large historical batches for batch processing, but now with real time streaming, there's continuous event streams. Can you talk a little bit about that and the difference between the two?
So earlier we used to have the data coming in at our doorstep more frequently, but now we are having the data coming in one by one, like within a second, within a millisecond. Data is coming in so frequently, and we want to handle the amount of data or amount of people coming in at our doorstep. Door, yeah, doorstep. So our house is limited, right? The house cannot accumulate large amount of people. That is why we should have enough space to accumulate those many people, and that's the easiest way to understand. We need enough storage for to accumulate high volume of data, because in real time we do not deal with thousands or lakhs of data, millions of data. We deal with petabytes, gigabytes is also old. Now we deal with petabytes of data. So think about data means people, like we understood. uh, Trillions of people coming in at your home after second by second. So yeah, so the question I can see that data processing has evolved to be ELT, not ETL. That's exactly right, Adele. Your understanding is actually true, and we are currently, most of the organizations are not currently using ETL. We are using ELT.
Amazing. Everyone is
Yes.
like following. Woo! And then
Yay.
yeah, we're super excited. So Hector even mentioned like ETL is a process similar to data analysis process, but it's the process of extracting data and cleaning it and transforming it, then loading it to send it to data centers. Is that correct?
Yes, correct. Absolutely right.
Amazing. All right, so let's move along strong. I think everyone is with us.
Yeah.
Cool. To the next slide.
Yeah. So, yes. So, how can we build a pipeline that we can trust, or the model can trust? Machine learning model can trust. We have multiple key components through which um, if we follow all of these components, then we could say that yeah, we can trust this model. So I'll not use um, tough words. I'll make it easier for everyone to understand. So first is data quality. Data quality meaning, we'll continue with the same example. So we want only the elite people coming in at our home or staying at our home. So that's the data quality check we follow. Are we good with that?
All right, folks,
Yeah.
how are we feeling about data quality and contracts? I think folks are understanding, but basically, we want to make sure that our data is clean and structured. Is that correct?
Yes, correct.
All righty. Yep, I see some thumbs up coming up. We can go to the next.
Okay. Next is data versioning and lineage. Meaning, let's assume like this. Lineage is relationship. So, grandfather is related to father, father is related to child. That's a relationship. That's what we call in a technical term lineage. So, we want entire group of relationship, um, grandfather, father, and his child to come at our place. That is what we want at our model as well. That data should be lineage and linked together. So linked together meaning, not um, it's not like how do we say? Yeah, it's not like a person who is a friend is linked. No, it's actual blood relation that we follow in this example. So only the accurate amount of data is linked together, and that's what we follow the lineage, and that's how the data is more structured and more advanced. So I am seeing a lot of thumbs up. Are you all following?
That's correct. It looks like folks are definitely following. Again, if you have any
Oh,
specific questions, please feel free to drop them in the chat. And for now, it looks like folks are following.
okay. Now, the third component is feature stores. Think about that your house is at a center place of your city, and all the main attractions are nearby, walkable. So, your house is at the city center. That's how we want the ML model to have. It should centralize the model, and it should purpose all the features in it, and it should always avoid the data skewness. So are we aware of data skewness? What do we know about that?
Let's see. I just see thumbs up. So anyone, everyone else? Yep, I see more thumbs up coming in. It looks like folks are following as well. And remember from Beam College, they talked a lot about this as well for those who are in attendance. So feel free to like kind of connect some of the dots here. But yeah, I think folks
Yeah.
are following.
Okay, I would still put out the easier thing to remember, so that everyone who is part of this session will never forget what does data skewness means. So whenever you see the term data skewness, just remember this concept that information is unevenly spread across. That's what the data skewness means. So that's the most real world challenge that every company, every organization faces, even the big tech. Um, so data is unevenly spread across. That is called data skewness. So I hope people will not forget this ever. Drop in any emoji if you are good.
Yeah, Is this I guess Togo says data skewedness is information when it's unevenly spread across. Is that correct?
Correct.
Mhm. Hector says he searched up data versioning and it says that it is similar to Git when you change code, but it has the history of previous code. Is it pretty much ensuring to keep old data with updated data?
Yes. I did not mention the example of Git because multiple people have come from non-tech background. But yes, this is absolutely correct. So we do or we follow the data versioning almost in every organization right now through Git. So whenever you build a code, you after some day you think that okay, this code needs an update. So what you do is you go to the same GitHub code and then you change, then you create a pull request and then you update that code. That is called data versioning because GitHub always stores the versions of data. So you can always go back to your pull request where you can see what was changed and what was it before and what it is now. So GitHub is a very good example to track the data versioning. Kudos, Hector.
Awesome. Yep, everyone in the chat is following. We got thumbs up, and folks are getting it. So, yep, let's move on.
Okay. So the final component in the pipeline is the monitoring. We create the visualization dashboards, and that is created. Okay, let's go back to one step before of creating the dashboard. So our pipeline is ready, but we want to make use of it. So what we do is we pull it live and we schedule it to run at every time. So let's say in this we want to set up a pipeline which runs at every night 10 p.m. So we schedule it to run at every night 10 p.m. That is called orchestration. And monitoring is we have a dashboard to monitor the pipeline. Is it working fine? Is it failing? What error it is showing? And how, that's with that error we can identify how to fix that pipeline. That's why orchestration and monitoring is very important because even if we have set up a pipeline, it does not guarantee that in all of the circumstances it will run fine only. That is why we are very um, we so much we focus on the orchestration and monitoring step. So are we good with that?
It looks like we are. I have another person that answered the question or asked the question. Oh yeah, that's correct. It's just the slides for right now. Any other questions? Topic from the back into my show. Okay, here's a question, or maybe just a comment. Okay, yeah, I think this is also good too. So sorry. Yeah, it looks like everyone has followed. We're good.
Yeah. So we can go to the next session. Yeah. So what have we learned so far? We learned how to design the pipeline. We also learned how the modern stack works and what all it consists and what has changed from the legacy stack to the modern stack. Now, we also learned how to apply all these learnings into the production ready model. So, you can you can pause and read out this, or I can also explain. So, yeah, let's go one by one. For the first designing and pipeline, one thing to note is we always design the pipeline in incremental way, so that we do not incremental way. How many of us are familiar with that?
Can you repeat that again? Familiar with which part?
No, it's not mentioned anywhere in the slide. I just wanted to let everyone know that we follow best practice to always design the pipeline in incremental way. So I am asking if anyone is aware what is incremental way. I can explain. So yeah, what does incremental means? Incremental, think about that. We build the pipelines in small, continuous manner. That's called incremental way. So whenever we follow to design a pipeline, we always build small batch first, then connect it, and then keep on building the remaining pipeline. Are we good with that? First we build first portion, then we build second portion, then we build third portion, and we connect all of these. This is a incremental way, step by step. Mm, Building the pipeline in small batches, then connect it. Yes, that's correct. Itogo. Awesome. Now, one of the best practices in the second point I wanted to inform is that we don't have to know all the tools at once. You master one tool and that's it. You work on it, you know the deeper way how it works, then you move along to another tool. You don't always have to juggle between all the tools at once. So once you are familiar with any tool, rest all is probably having the same, I would say, working model. Only the change is the UI. So that only you have to bother about. Otherwise, all the functioning is same. Just that key components naming or UI might change. That's the same case when it comes to data visualization tools as well. So components are can be different, but the way of working in depth. What do we say? In depth. Yeah, working only. So in-depth working is same, and only the UI is different. Let's say Power BI, Tableau, Looker, all of these works the same way, just the UI are different. And you don't have to master in all the tools. You just know one, and then you can follow along in any of the tools. So are we good with that? Yeah. So your question is, which system are we using for the ML task? Is it cloud based or what? No, not always cloud. We can have on-premise tool as well. For example, we have in the screen itself, you can see DBT, Kafka, Airflow, Delta Lake. All of these are, uh, you can say, modern stack which we follow. Some of it are on premise and some of it are cloud based. So it doesn't matter where you build the stack. It matters how you build it, and you build with all the taking care of all the four components that we discussed in the previous slide. So yeah,
Amazing.
I'm seeing a lot of thumbs up. Yeah,
There's
we
another
can go
question
to
that's
next slide.
okay.
Okay, how to decide which tool to use? Yeah, so for example, you are working at an organization. That organization is already have the set of tools which they are allowed to use or they want to use. So one logic is that, so whatever is available at that organization, go ahead with that. Otherwise you have multiple processes to compare, multiple components to compare, which model, sorry, which tool is compatible at which situation. So situation wise also you can sort out which tool to use. So for example, we have multiple cloud platforms, we all are aware, hopefully: AWS, GCP, Azure, Snowflake, Oracle, Informatica. Let's keep it to this. So how do we decide which one to follow? First of all, in the first example, like I mentioned, which organization is which organization allows us to work in that tool, or that organization have multiple tools and you have to decide which one to choose. How will you decide? You decide by, let's say, first example, cost. Which one is cost effective? um, we always do not want to build the best model, we always want to build the cost effective model as well. So we have to think about cost, because um, client doesn't deal with thousands of dollars, they deal with millions of thousands of dollars. So we have to think about cost, and we have to think about effective ways of using the tool and right tool in logical way. Hope that makes sense, Divya.
Yes, looks like everyone is definitely following in the chat. Um, Io said it's building like it's in a arithmetic plus a progressive manner. And then we had other folks just still following. So, yep, doing great.
Okay, so let's go ahead with this slide. This is the real-time ETL pipeline, which has ingest, then process, then store, and then serve. So I have mentioned as part of GCP platform. In the ingest, we use PubSub. Then the process, we use data flow. In the store, we can use BigQuery or Vertex. And then let's leave the Vertex for now. We can use BigQuery, simple and easier to remember. And then we on the serve or maybe monitoring, we use Vertex AI. Okay. So now key fact. So you all can pause and read out this slide or take a screenshot. I'll just mention key component in just a bit. I'm looking at the chat. So yeah, things to remember is PubSub is stream versus batch. BigQuery is we should follow the partitions, and then we also need to think about cost. We also think about the latency. Then there is no right data set. Whatever data set the model is trained on, the model has to predict that way. And yeah, any questions on this? GCP meaning please. So GCP is Google Cloud Platform. Short form is GCP. Yeah.
Awesome. Thank you so much for going over that. Yeah, and I know again a lot of these terms or what is it called? Shorthand terminology may be new. But I want to encourage you all to please leverage Gemini to ask it questions, right? Like we want you all to master this, not just kind of be fed information. So as Avantika has been doing a great job of explaining, I want you all to take some time to just go into it a little bit more in depth. But yeah, back over to you, Avantika.
Yeah. So I hope everybody has read out this slide. So think about the topics that I have mentioned. Why do we need stream, or why do we need batch? Which data we have to design, which partition we have to follow, and how we have to train our data. Okay, so that's what you can look up at Gemini as well. And yeah, let's see if anyone has the question on this slide, or we can move along to the next slide.
I think we're good. Yep, we can go to the next slide.
Okay. Yeah. So this is what I wanted to talk about the most, and it's about how AI is actually helping our organization. And so I'll give an example. Think it this way: if your team started using GitHub Copilot tomorrow, so you are in an organization, and right now everyone is aware that we should be up to date with AI. And now manager has informed everyone that entire team has to use GitHub Copilot from tomorrow onwards. And organization is tracking the usage of AI, how we are using the AI at personal level. So how would you know actually 6 months later whether it made our teamwork faster, or would you just have a feeling that okay, team is working good, so we are good with the AI? No, uh, feelings don't get the budget approved in the real world scenario. So we have to actually use GitHub Copilot or any form of AI Copilot in the work, and we have to actually track it. How do we do? Even start with a simple um, task. For example, how long does it take your team to write a code today, or how many review data model has to go through, or how often do your pipelines have failure. So write those numbers and then measure the same things after using AI after 3 months later. So after 3 months, what you will see that AI has reduced all the number of pipeline failures per day. It has even reduced the number of review model has to go through, and it also reduce the number of times, number of hour a teammate has to write a code per day. That's how we track the usage of AI in an effective manner, and that's how right now the organization is tracking the usage of AI, and that's how AI is getting leveraged by organization actually. So yeah, do we have any question with that?
No, I think we have a question in regards to just data in general. Um, so Chimdina says, thank you so much. For someone who is still very new to data analytics, do you think that we need to master these tools you're teaching, or should we focus on mastering Excel, SQL, Tableau, and Python?
Yeah, so that's a good question. If you are in data analytics, I would say master one thing, then jump out to another. We all in the data. Um, so we are all data practitioners, and we should be aware of what all new technologies is coming, and how it works. So if m- like I said before, master one thing and then jump out to another. Everything is same. If it, follows under same topic. For example, data ingestion. So there are multiple topics. For example, Azure has Azure Data Factory, BigQuery has another, then AWS has another. So if you are mastered in one stack, you are already aware on the working of all the similar ones. So just go step by step. And like I mentioned in my previous slide, this is how you should follow if you are interested. Go to ingestion stack, then go to process stack, then go to storage section, and then go to monitoring. And if you are from data analytics, or if you are just starting out or business intelligence, I would suggest to learn Python, SQL, and Excel. That's the basic. Then jump out to, if you know SQL, you already are aware how BigQuery works, because that's also based on SQL. You already are aware on Snow SQL, which is Snowflake query language. Then you are already aware of Cosmos, which is Azure query language. Similarly, if you are mastered in one thing, you are mastered in rest all similar stacks. So go one by one and step by step. Hope that helps.
Yes, looks like it does. So master one thing and then jump to the other. Awesome. Over to you.
Yeah. So, yeah. Do we have any question on this? How AI is helping organizations, right?
I didn't see any questions about that thus far. So I think
Okay.
we're good. Yep. Amazing. So it looks like we're at the last slide. Is that correct?
Yeah, and you can reach out to me on my after scanning this. You can see my LinkedIn, and you can reach out to me there, and I'm happy to connect with you all and answer your beautiful questions, or maybe share some resources which are useful for your learnings.
Amazing. We have so much love in the chat with everyone saying thank you. It's such an informative session as well. We're super excited again to have had you on. For those of you who have specific questions, you can feel free to drop them below. If you don't, again, just let us know where you are tuning in from as you all are hopping off. And if you are a scholar, please make sure to let us know what your takeaway was. This was an incredible session, so please make sure to post your takeaways in the Slack. Amazing, amazing, amazing. Look at all the love in the chat. Phenomenal, phenomenal,
Thank you all.
phenomenal. Thank you. What was your favorite part about your talk today, Avantika?
Yeah, my favorite talk was to answer with the basis of an example. Like I mentioned, the number of people coming in at our home. That's what I am thinking about right now.
I love it. I love it. And I know that you're based in India, which is amazing. I know it's super late. So thank you so much for doing this session with us at this time. We just
No
really appreciate the
problem. Happy to
dedication.
help. Yeah, this was
Thank
actually
you.
on my wish list for so many years, and I finally did it. So I'm actually proud of myself, and I'm grateful for you and Girls UML who gave me this opportunity to actually be at the center stage and be a medium to answer all these lovely people with their lovely questions.
Oh, I love that. She's so incredible. So throw some hearts in the chat as you all are exiting out. Let Alpha know that we're super thankful for her. Because she is a part of our ecosystems, you can totally ask her continuous questions in the chat. Again, we want to thank Girls Who ML for helping us to co-partner on this incredible series. We're super excited because next week we have another one coming at you as well. We'll have another individual joining us, and we will be focusing on an incredible topic called model compression and optimization, making AI
Yay!
models faster. So we are building our knowledge step by step, And again, we see all of the love and the hearts in the chat. Thank you so much, Avantika.
Most welcome and happy to be present here.
Amazing, amazing. All right, everyone. We wish you all a wonderful rest of the, I guess, day, evening, morning, wherever you all are tuning in from. We look forward to seeing you next week. Bye.
Think I've been here before. I know that I must have met you in a past life. Got my heart on the floor. Go slow. Keep me falling for you all night. Tell me now, you're the one I've been dreaming about for my whole life. Had you on my mind, oh. Hear the sound of your voice in the crowd, calling my name. Yeah, you captivate, oh. You captivate me. Cover me in a dream of love. You're pulling on my sanity, it does seem. I need you next to me. Can't get enough.